Hello everybody, I'm Nick, and in this video we're going to take a look at 5 things that you should know about in .NET and C#. These are tips and tricks that will generally make your code better or run faster, and there are also things that you might not know that you're doing wrong. These are the 5 topics that I'm going to cover in this video, so if you're familiar with one of them based on the title, feel free to skip to move to the one you're interested in by using the timestamps below. This video is part of my 5 useful .NET tips and tricks series, so if you don't want to miss any episode, please subscribe and ring the sub notification bell to get notified when I upload a new video. So let's start with the first one, which is that async actions are not awaited in C#. What I have here is a main method, a main async task method, and within that I have another method that I own. It's a static method here. And then this method has an action as a parameter. So what happened in this piece of code is that I am asyncing this action that you see here, which contains a task delay and a console.writeLine_test. So just by looking at the code, what this should be doing is awaiting this method, this async method, which has its own delay. It's a fake delay to pretend like it's doing some stuff. And then I'm asyncing the action that's happening here with its own delay for a second, and then I'm printing something to the console. So if I go ahead and run this using the debugger, as you can see, I don't actually see anything printed. So this is weird. Something's clearly wrong here. To understand what's happening here, let me give you a bit of an example of what an action is very quickly. So effectively, what you see an action being here is very simply a public void test method. So an action is effectively a delegate that doesn't return anything, and it can actually accept things as well. So if I have a string here, for example, then it's the same as this. In the same way that if you turn a void to async, you have an event and not an actual task, an action cannot be awaited because it's treated as an event, meaning that even if you have async stuff and you await, the execution of it as a lambda, as a delegate here, will not be awaited. So how do we fix this problem? And actually I've seen this in many NuGet libraries, and I've seen in many different code bases as well. So this is a very common one. So what do we do to fix that? Well, first and foremost, you're going to go to the action and you want to simply change that from an action to a function, a func that returns a task. And now you can actually properly await it internally as well. And what this will do now, and as you can see, I'm going to run this, is it will wait for 1 second in here and then print the test. So now properly the code will be async and it will be awaited before the program finishes executing. So this is one of the very common tricks, just that async actions are not awaited because they're treated as events. And that's the first tip of the video. Now for the second tip, we're going to take a look at get or add in the concurrent dictionary is actually not thread safe. So let's take a closer look to this method. Now, for those who don't know, the concurrent dictionary is a version of the dictionary collection, which is generally thread safe. The way it achieves that is that its methods are effectively locking, meaning they prevent other threads to access them. An example would be that something like the dictionary dot try add or try get or try update or try remove, they all internally, if I quickly decompile the code and step into the code, they will acquire a lock. As you can see, the pointer is entering here, and they will only allow one thread to manipulate that. The problem is that one of the most common methods of the dictionary is the get or add method. What this method is doing is it accepts a key, let's say key here, and then it accepts a value factory, or a value, but usually it's used with the value factory. And this value factory is very similarly a function that accepts a string and returns the string that you want to add. And what it's doing is it's checking for this key if there is a value in the dictionary. If it is, it returns it. If it's not, it will use this instruction, this function here, to create it and add it. So it's effectively one call to do two things, a check and an add. Now, the problem with this method is that it is not actually thread safe, and we can very easily prove that. We can simply run this in the debugger, and you will see that what you get here is actually pretty normal, right? Because what do you expect? What I have in the code, let me just explain it. What I have in the code is two task.runs, which will asynchronously run two tasks, and then I'm gonna await them, so they will execute in parallel here, and they will be awaited until they're completed. And then a synchronous one where I'm just adding some key, and all I'm really doing is I'm adding this value into the dictionary. So this is all it's doing. It's taking some value, it's using the same some key, and then it's adding something as its value. Now, you can see by this returning first call 3 times, that what happens is the first call task completes first, so it adds the missing value, and then the rest of the calls are being ignored, and what happens is it's just getting the value using the key, and it returns it. Now, if I run this again, and just to make this clear, I'm going to run this a couple of times. As you can see now, it returns the second call. This is fine. The reason why this is happening is because of these tasks running in parallel. One of them will run first, and it's very likely that the second call will actually run first, and then the first one will run second, so you will not see it here. The problem is not that. This is expected behavior. The problem is that if I create a private static, let's say visitor count, and set it to 0, and this needs to be, of course, an integer, and I put that into the method right before the call text, and I could say increment, but this is not thread safe. So what I'm gonna do instead is I'm gonna use the interlock class, interlocked.increment, and then I'm using the reference of what I wanna increment, and this will effectively do the same ++ increase, but in a thread safe fashion. And at the end, I am going to do console.writeLine called, and let me just use this feature, called visitor count times. Now, if this was thread safe, what I want to see is this saying called 1 times. If I see 2 times, this will mean that it's not thread safe, and I expect it to not be, because this method is not thread safe. It's not acquiring any lock. How can we fix this? Well, this is very important. There's a very easy and clever way to do this. What you want to do is, instead of having a dictionary of string and the thing you want to store, you want to have a dictionary of your key type and the lazy version of the type you want to return. The reason why you do that is because having the lazy there won't do any compute as it's adding it, so it will only be called once. It's a weird and nice mechanism, but I'm gonna link a link in the description down below explaining this process in depth. And I'm gonna keep this here, but what I wanna do, like I said, is I wanna, and let me just quickly delete that, is I wanna return a new lazy string here, and I'm gonna use the function approach, and I'm gonna just paste the same code actually right here. So this is the code we had before. Let me just reformat it real quick. So same thing, but now it's a lazy, and instead of printing the call value, we need to do the dot value, and this dot value is what will effectively trigger the lazy class to be computed. Let's go ahead and run this now, and as you can see, it is only called 1 times. Remember, this does not guarantee that this will come first and this will come second. These are running in parallel. There's nothing we can do about that. I mean, technically there is, but we don't care. What we care about is this method being called 1 times, the delegate method that builds the value for the key to be called 1 time. And I can run this again. You can see that now it says second call. This is because it will not guarantee ordering, but it will guarantee that it's only visited 1 time only. And this is an issue I see all the time as well. This is a very common one, very easy to fix. Just use lazy and the type you want to return, and don't call value until you actually need it. Now for the third one, we're gonna go to something you might actually be familiar with. This is a very common one, but I wanna show you a better way to do what we've already been doing until now. So what you have here is you have a project which has a single class. It is a class to test, and it only has internal classes and internal method. And the internal method boolean is Nick creating YouTube videos, return true. Very simple method. And I also have a test class for this. Now, usually the naming convention for test classes, for test projects actually, is the name of the project that what you want to test belongs into, and then .tests at the end. This is the naming convention I've seen widely used, and I like using it as well. So in this example test class, what you might want to do is test this internal method. Now remember, internal is not like private. Private methods should be tested indirectly by using the public methods that are calling them. Internal methods are effectively like public methods, but you're hiding them from the consumer because they don't need to know about them. But your code needs to know about them in order to test them. There's no other way if they're not exposed publicly, and it could be very complicated to expose them publicly. So what you want to do instead is you want to create a new class here, and you can call this whatever. I'm going to call it internals visible or something. It doesn't really matter. And what I want to do is I'm going to delete everything that it contains, and I'm going to say assembly internals visible to, and then I'm just going to use the project name that I want the internals of this project to be visible to. In this specific scenario, it's internals visible for .tests. And actually, let me just comment this out and go back to the example tests. And I'm going to say test class equals new class to test. And as you can see, what I'm getting is a warning saying that you cannot access an internal class here. So what I'm going to do instead is I'm going to go and uncomment this assembly internals visible to. And as you can see going here, unless I misspelled that, I totally misspelled that. Let me just copy this and paste it. Yeah, I missed the for test stuff. So if I go back, now I can access it, and now I can call the private methods, and this should be true. Now this is a nice way to do it, but I think there's an even nicer way to do this. I'm gonna go ahead and delete this class, and now again, this is unreachable, this is internal. And what I'm gonna go instead and do is I'm gonna go into the csproj file, and I'm going to add a new item group. And in this item group, I'm going to create an assembly attribute, which instructs it to include the following namespace. And let me just copy that because it's boring to just simply type it out. And this namespace is actually the same namespace that the internals visible to class that we used belong to in the class we just deleted. And the whole point of it is to just provide this. Basically here, you need to say underscore parameter 1, because we need to provide the parameter for this class, for this assembly attribute. And all we need to say is $assign assembly name, and this is effectively a variable. It will use the assembly name here, .tests. And assuming you're using the convention that I talked about, the .tests convention, as you can see now magically with code, our class is accessible. Of course, if you are not using that convention, you're going to have to go ahead and actually type the thing you want this to be visible to, and this will also work. But I prefer this because you can just have it as a templated thing in your project, and then automatically all your internals will be visible to anything that you want to test this project with. So that is for number 3. Now the fourth one is called auto property versus expression bodied members. Let's take a look at the employee class here. So what you have here is an employee class with a constructor which gets the first and the last name of a user, and then it uses effectively what is called an expression bodied member to concatenate the first name and the last name to create a full name. Now, I know this is not the proper way to do the full name, but just for the sake of this example, this is the example I'm going with. So what you have here now is what seems to be a get only, read only property. In reality though, that's not what you have. If I open Riders IL viewer and I build my project, so it's building what I want to show you, what it's doing here is by clicking that, I can actually show the code the compiler will generate. That's what we're taking a look at, the intermediate language. And I can show you that what will happen here is it will use the get first name and the last get name and the get last name, sorry, and will concatenate. It will use a string.concat method to create a string. This, because what it's making behind the scenes is a method, a property really is a couple of methods with a backing field. So we can actually quickly take a look at that. As you can see, the last name property has a get last name, and the set last name is not there because it doesn't have a setter. But if I go on at the very top, sorry, you can see that the last name has a backing field, just like a normal field. Like, actually, let me just show with code, private string first name, same type of thing. So like I was saying, what happens here is this is not really a property, it's just a method that will be called every single time you're calling the full name property, quote unquote, which means that the concatenation method in this string will be allocated every single time you call this method. You don't really want to do that. What you want to do instead is, because this is based on read-only properties, is you want to actually do that in the constructor and have the full name be computed once, and then have a proper read-only string here. And as you can see, if I rebuild that with the code updated, now the full name is a proper get-only full name method, with the getter being give me the value of the backing field. So now it has a proper backing field, while before it was just a method computing a string every single time. And then if I go in this code, it's the same thing, but concatenation is only happening once. And then the value of the concatenation, let me just make this a bit bigger, and then the value of the concatenation is pushed into the backing field for full name, and it only happens once. Now this might look very simple. You might say, okay, Nick, this is not a big deal. What happens? It's just a string computation. Well, actually, this can be used, the same expression bodied members feature can be used for pretty much anything. And what you need to understand is, if you do this, whatever you have on the other end will be put in a method, and effectively what you get out of this is this, a method that returns whatever the body is pointing at. So you need to understand that you're recomputing that every single time. And if it's a constant thing like a string, it's probably fine, but it can be anything, and it can have compute in it as well. So you need to understand that this is how it will behave. Now, last but certainly not least is understanding how enumerables work and how collections work and how lists work and how LINQ plays into that. So I'm going to go to this project and I'm going to show you the following code. So what I have here is a benchmark runner. We've covered what benchmark.net is in a different video. You can find that in the top right corner of your screen right now. And then I have a class that I want to test, but all it's really doing is it's creating a list with 10,000 new GUIDs. And then I have two benchmarks, one that checks the list.any to check if there are any GUIDs in the list, and a list.count more than 0. So the outcome is effectively the same, because it will tell me if I have at least one into my list. But if I choose, and actually let me just change this to release because it needs to be released. If I run this benchmark with the code, one using LINQ, one not using LINQ, let's see what I get back in terms of performance. So as you can see, the test count, the one that's just using count more than 0, is actually significantly faster. Of course, we're talking nanoseconds, but that's besides the point. It's significantly faster than the usage of LINQ. And that's because count actually knows the number beforehand, because it's effectively computed. It's a list, and the count is a property of the list. While any, being a linked method, it will need to go through the getEnumerator method and then use the move next to see if there is at least one element in the list. Now, obviously you might say this is no biggie, but here's where it becomes tricky. you see this is a property, but what happens if the list is not actually a list? And I change this to, actually I can leave this as a list, but what I can do instead is I can create a public IEnumerable GUID list date, which returns the, let's just return the list for now. I'm going to expand on it in a second and change that to this. Now, as you can see, count doesn't actually exist as a property anymore. Now, count is gone and it's replaced with what is a method. And the reason why that happens is because the IEnumerable interface can be anything. It can be a collection, it can be a list, it can be anything that can be enumerated. So the interface itself doesn't know if the count is computed or not, which means that if I click on that, now this is turned into effectively what is LINQ, and we'll do some checks to see what type of collection or list it might be to be more efficient. But if it can't find any, it will just go through the enumerator again. Now, this will effectively perform in the exact same way almost if I run this, so I'll spare you this execution. But what I want to do instead is I'm going to return this, I'm going to delete this actually, and I'm going to change it to for each list, and I'm going to say for each item in the list, yield return the item. And yield return makes this a true enumerable in a sense that it's not computed, it's not backed up by the list data until this method is actually invoked. Which means that now executing these two will actually perform different. And let's just run them to show you what I mean. Now the test count run significantly slower than the any. The reason for that is actually pretty simple. Count will wait for all the iterations of this enumerable of yield return to actually be completed to get the exact count before it does the check on whether it's more than 0. While any will only do it once to see if it has any elements to move next. So what you effectively need to understand, and the reason why I'm mentioning this, is you need to understand how the difference between the method and the property works. Generally, if count is a property and it's not a method, it means that you can call it and it will be the fastest way to go about it. And if you know that the backend field is a list, you don't have to use an enumerable, just use a list. Unless you need it to be an enumerable, in that case, use an enumerable. But beware that it might actually have a huge difference in performance, as you can see, depending on what it is. So make this predictable by understanding what is backing up my data, what type of collection I'm using, and what's the best way to do my check. LINQ can be very clean and pretty fast, but it can actually be also a pitfall for your performance. So be very careful when you use it. It's very useful to decompile these codes and see how they work behind the scenes, and things like benchmark.net make it very easy to test those methods. That's all I had for this video. 5 very simple tips that you can actually use to improve your code. I hope you learned something you didn't know. If you did, leave a comment down below. If I missed something and you want me to talk about it, leave also a comment down below. Special thanks to my GitHub sponsors for making these videos possible. If you like what I do and you want to support me, you can use the link in the description down below. Leave a like if you like this video, subscribe for more content like this, and ring the bell as well to get notified when I upload a new episode, and I'll see you in the next video. Keep coding.